the following: that the center of the Ferris wheel is 60 feet above the ground. The radius of the Ferris wheel is 50 feet. So here we have our Ferris wheel. Here's the center. They tell me that the center is 60 feet above the ground and that the radius is 50 feet. So that's 50. Here's the ground, so this must be 10. And this is 50 more. It then tells me that it takes 8 minutes to complete a revolution. 8 minutes for a revolution. And it travels counterclockwise, so we're moving this way. Okay. Assuming that your height is given by the height of the point where the car connects to the Ferris wheel. In other words, if you're at this point, your height is 10. If you're here, your height is 110. Sketch the graphs and analyze them. Okay. Part A. Sketch a graph which represents the height above the ground of the person in car A from t equals 0 to t equals 16 minutes. Find map, maximum, minimum. Okay. When we say map, we mean midline, amplitude, period. When we say map, we mean midline, amplitude, period. So they want us to find midline, amplitude, period, max, and min, and draw the graph. Okay. So, map. I always like to start with the max and the min. Those are often easier. Often, not always. Okay. So I'm in car A, so I start off up here. The maximum height I could have is 110 feet off the ground. The 10 feet here, the 50 here, the 50 here. I can't go any higher than 110. So my maximum height would be 110 feet. My minimum height, in other words, when I get down here, will be 10 feet. You have a pass, Jessica? Okay. He'll email me or something? Or you want to go grab one, please? 10 feet is the minimum. Right? 10 feet is the minimum. So now it is very doable to get the midline and the amplitude. So the midline, right, we say max plus min divided by 2. 120 over 2, so y equals 60. If we don't have units, we will take off. If we don't have the y equals, we will take off. Right? We're going to hold people to a high standard. Now the amplitude, we know, is maximum minus midline. So it is 110 minus 60, so the amplitude is 50. And the period, right, how long does it take to make a revolution? Well, in this case, 8 minutes. 8 minutes. So any questions on map, max, or min? Carla.
Do you have to put y equals 60 feet or just y equals 60?
Great question. Do you have the same question?
No.
Okay, so let me find the answer to this. Mr. Kirk, can we ask you a question here real quick? Do you mind coming in here? Thanks, man. Okay, I'm not sure the answer to this. So we're doing the periodic functions, right? And they find the midline as 60. So we write it as y equals 60. Do we need to write y equals 60 feet? I honestly don't know. Or do we just keep it as a number?
I don't know what you need. I don't think you can ever go wrong by putting units. I think anytime you put units, you improve the answer.
Okay.
But, right, like what are we saying here? Like the average height is 60. right?
Right, so the height, like in between, so the max is 110, the minimum is 10, so the average, right, would be 60 feet. But it's a line, y equals 60, because it's a graph that goes on and on and on forever.
The average between 110 and 10 is, 60, yeah. Right.
Okay, cool, thank you. I honestly didn't know the answer. He's a veteran math teacher. Highest scores in the district. Okay, so I think it'll be nice if we write y equals 60 feet, and I'll make sure that I do that on my answers as well. So we're all holding ourselves to the same standard. Brenda, you had a question as well.
Is it always going to give me the time revolution?
Yeah. So like usually they'll say like it takes 8 minutes or it takes 4 minutes, or they'll give you the picture and be like, how long does it take, and then you can calculate, right? Like 2 pi, because it goes from here to here. It takes 2 pi. Take this x value, 2 pi, minus this x value, 0. 2 pi minus 0 is 2 pi. Okay, yeah, good question. Okay, so let's draw the graph. So, let's draw some axes here. All right, and gonna call the x-axis time. Gonna call the y-axis height. In feet, time in minutes. All right, and let's see what they want us to do. Well, at time equals 0, how high is the person in car A?
160 feet.
160 feet. How'd you get that, Mio?
50 plus 50 plus 10.
Is equal to what?
The max height.
Which is equal to?
110.
Oh, sorry. Okay, yeah, 110. Sorry, I thought I heard 160. Oh, okay, gotcha. Okay. Got it. So 110, right? That's where at time equals 0, like right when I click the start button on the Ferris wheel. You all have been on Ferris wheels, maybe on the trip to Kima, whatever it might be, right? Right when we click 0, right when we click start, the height is 110. Okay. When will this person get back here? At what time will they be back at the top? 8 minutes, right? 8 minutes. We're measuring in minutes, but yeah. 8. So let me go ahead and mark that here. So 8, they're back up here. And then if they're back here at 8, they're also back here at
16.
And I could go on and on, 24, blah, blah. But they only want me to graph it up to 16. Okay. Now, when is car A down here at the minimum? How much time?
4 minutes.
4 minutes, right? Half of the 8. So down here at 10 at 4 minutes. So let me call this 10. Call it 4 minutes. So we're here. And if it is there at 4 minutes, it must also be there at 12. This is the notion of the period. The values repeat every 8 minutes. So call it 12 here, and now we can connect the dots. So this is how the person's height goes. Start high, come low, back up, back down, back up, and depending on how long the Ferris wheel goes, right, he or she will make blank number of trips up and down. Now, if you notice, this graph looks a lot like this graph. Next week, we will learn how to write that as a cosine function. That's where we're going. How you can write an equation for that as y equals some very complicated cosine function. Okay. So any questions on this piece? Okay. So why don't people try B on their own? Notice the very subtle difference between A and B. I'll model B on the board, but most folks should be able to try B on their own. Hmm? No, B. Sketch a graph which represents the height in the person in car E. Part B. Excuse me. Part B. Part B, not car B. Part B. Excuse me. Part B?
Yeah.
That's what we're doing right now. Okay. All right, so here's the picture, and again, if you need some support, you can look up here. I won't talk much because I want to give people who are doing it on their own a chance to try this. So here's what we have on the board, and again, obviously don't check it until you feel like you're at a spot where you want to sort of get feedback on how you did. If you have questions, now's a great time to ask about how we got this. Those who are confident with this, I would say move to D. So I'm going to do part D next, then we'll come back to C, but let's do D. Try to understand what D is saying. It's a little bit different type of question. And again, those who have done, this is part B. If you're good with this, move to D, but I'm going to wait here for another about minute to see how folks are doing, and then I'll move to D. This, which one? All of this is the same, right, yeah. Mm-hmm. Exactly. But the graph is different, Rafi? You got the different graph. Jenny? Because I knew that at time equals 0, we're here. Because I'm modeling the car E. So in 4 minutes after, so 8 minutes later, he's back here. Because it takes 8 minutes to go around once. So that means it'll take half the time to come to the top. And half of 8 is 4 minutes. Does that make sense? If it takes you 1 minute to walk from here to Reyes's room, it would take you half the time to go from halfway from here to Reyes's room, right? So if it takes me 8 minutes to go all the way around, it'll take me how many minutes to go halfway around? Half of 8 minutes is. So that means at 4 minutes, car E will be here. Right? And car A would be down here. So 4 minutes later, car E is up here. And when car E is up here, what is the height? 50 plus 50 plus 10, which is 110. Marvin, did you have your hand up?
Should there be straight lines somewhere?
No, yeah. You're right.
But isn't it like the cosine and...
Yeah, so this one will be a straight line because the slope is constant. Those are not straight lines. Most times it'll be like that.
So whenever we do the cosine and sine...
Say that again? Yeah. Sorry, repeat your question. You're right, Marvin. Repeat your question.
So whenever we do the cosine, is that be different?
I mean, we assume it's the same. But you're right. Technically, it is different. You should have a... I mean, you can write this with this equation if you adjust some things. Like, you can adjust some, like, you can, like, multiply and add stuff on there to make that look like this. And that's what we're going to do. Okay, I'm going to move on to part D. Carla, you have a question on B? C, okay, yeah. So I'm going to skip C. I want to go to D first, then I'll come back to C. I want to go to D first. So let me go to D now. So D, and again, some people might be able to do this on their own. Great. In part D, they say what? We're looking now at car C. So here's car C right here. And they want me to know what happens to car C if the speed is doubled. If the speed is doubled. Well, still, even if the speed is doubled, the maximum is not going to change, right? The Ferris wheel isn't any taller off the ground or any shorter. Still the exact same Ferris wheel. So my max is still 110 feet. Right? The highest point for car C is when it gets to right here. That's when C will be the highest. Aldo.
Wouldn't everything be the same except for period?
That's right. That's absolutely right. The minimum is still 10 feet. That's still the lowest we can go. The midline, well, the same formula, 110 plus 10 divided by 2, so 120 over 2. So y equals 60 feet. The amplitude, remember, is max minus midline. Max minus mid. So 110 minus 60, so that's still 50. But the period, it used to take 8 minutes, but I'm twice as fast, so how long did it take? 4 minutes. That's a very nice song by Justin Timberlake, by the way. Does anybody know that song? 4 minutes?
4 minutes.
Yeah, old song. It's good. Okay. So let's notice what happens. At time t equals 0, at time t equals 0,
60.
car C is at 60 feet off the ground. Why? The 50 feet radius plus the 10 feet that the whole Ferris wheel is off the ground. So at time t equals 0, the car is at 60. And that means it must be back at 60 when? At 4 minutes and 8 minutes and 12 minutes. So I'm going to put those points in. All right. So it takes me 4 minutes to go all the way around. So it takes me 2 minutes to get here, because this is halfway. So how many minutes does it take for me to get to the highest spot?
2 minutes.
1 minute.
Well, so it takes 2 minutes to get here, 4 minutes to go all the way, 2 minutes to go halfway, so 1 minute to go a quarter of the way. Did that logic work? If not, Carla? Mm-hmm. So 4 minutes to go all the way around. Does that work, Carla?
Mm-hmm.
So 2 minutes to go halfway around. Does that work?
Mm-hmm.
So therefore, 1 minute to go half of the half, or a quarter. It broke down there. Okay. So 1 minute later, I must be at 110. So 1 minute after that, 1 minute after that. You could even write in the 1, the 5, the 9, the 13. Okay. And when do I get down here at the lowest point? Well, 1 minute to get here, 2 minutes to get here, must be 3 minutes to get here. So at 3 minutes, I'm at the lowest point. At 7 minutes, I'm at the lowest point. At 11 minutes, I'm at the lowest point. And at 15 minutes, I'm at the lowest point. So we go up, down, up, down, up, down, up, down. And there you have it. Notice this graph is a little bit tighter than the previous graph because the period is less. So in other words, it gets around quicker. The Ferris wheel is moving quicker, so I have more up-downs. Questions? Okay. In part C, what it should have said is, because it got cut off, assume that the Ferris wheel continues to complete one revolution every 8 minutes. So I'm back to the 8-minute period. In a 2-hour, it should say 2-hour period of time in part C, it should say in a 2-hour period of time, when is or at what times will car H be at the highest point in a 2-hour time? When is car H going to be at a highest point? And H starts off here. Here's H. When will H get to the highest point? Remember, we're going, which way are we going? Counterclockwise. So when will H first, how long will it take for H to get to this highest point? It takes 8 minutes to go all the way around. How long will it take for us to get to here?
37.
Let's find out. So the whole thing is 8 minutes. So all this is 8 minutes. So it's going to take me a little less than 8 minutes, right? A little less because I'm not going all the way. I'm just going up to here. And it's going to be 7 minutes. Why? Because there's one stop every minute. So H goes to G, that takes 1 minute. G to F, that's 2 minutes. F to E, 3 minutes. E to D, 4 minutes. D to C, 5 minutes. C to B, 6 minutes. B to A, 7 minutes. So it takes 7 minutes to get to the highest point. If it takes 7 minutes, then it also takes... so herein lies the challenge. 15. Why 15? Because the period is 8 minutes. So the values repeat every 8 minutes. This is the key with the period. The period says, when do the values repeat? And they repeat every 8 minutes. If you remember in part A, we said car A is at the highest at 0 minutes, and then 8 minutes later, and then 8 minutes later. In part B, you all said that car E is at the highest at 4 minutes, and then again at 12 minutes. Why? We added 8 minutes every time because 8 is the period. So here, this car is the highest at 7 minutes, and then 15 minutes, and then 23 minutes, and then 31 minutes, 39 minutes. You all should finish this off all the way to get to the end of 2 hours.
So you multiply it by every period and then subtract it.
You just...
You had 8.
Yeah, I was just gonna... So I think it's easier to think about it as adding 8, because 8 is the period. I think that's... But what you are saying is right, and the reason is because this is one space away. So what you are saying is correct. But I think an easier way is just to remember, add the period. Because the period is how often the values repeat. So we should keep adding, so you should get something like what I'm getting up here. Please verify that you get all of this. Question, go ahead, Brenda, please.
Isn't it like basically multiples of 8 and then subtract by 1?
Right, yeah. So this was Jasmine's point, and that is right. I think it is easier to remember because that rule is working in this example only. It is better to remember it as whatever you have, add the period, and the period's 8 minutes.
But then like we have 34 there and like a multiple.
Where's 34?
Or is it
This is at 39.
39? Oh. Oh, okay. No.
Okay. This 96 should be a 95, 103, 111, 119. So this is what we should have. These are all minutes. And of course we stop at 119. Why?
Because
We're only going for 2 hours. And 2 hours, as you all know, is good. I used to remember being in my 3-hour lecture classes at Rice, and I would be like, okay, there's 180 minutes that I'd multiply by 60, which is like, I don't know, it's 18 times 6, 5,400. And then I would literally start counting because I was so bored. 1, 2, 3. And then I was like, when I get to 5,400, I'll be out of here. because I was so incredibly bored. That didn't happen that often, but sometimes it certainly did. Okay. All right, so let's go to page 4. Let's go to page 4. All right. Let me stress on page 4. Let me stress a couple things. All right. If you try to rush through these graphs, you will get them wrong. What I'm about to do. If the graphs are not clean, I will mark it wrong every time. What we should see are colors. Should be clear, one graph per page. If you try to scrunch it in, I'm talking to some of the males in the room who like to do this. I was one of you in high school. Don't do it. Take one paper per page, buy some colors. If finances are a problem, let me know. I'll provide them. But we need to take it slow. You need to do it the exact way I'm going to tell you. If you try to cut some corners, it will not work, and I will count off if it is messy. I'm not going to try to read the messiness. We're past that. I'm not reading the messiness anymore. So it's crucial to follow as I do this. So I'm on page 4 at the top, y equals 3 sine of 2x minus whatever it is. This stuff, what I'm about to do, is hard. It is not easy to draw these graphs. You can ask people from last year. It took a lot of time for us to draw these graphs. Your Thanksgiving packet will have several of these to do. Okay? Now, let me jump right in. By next week we'll be graphing something like this. You don't have to write this down, but this is where we're going next week. That's what we'll graph next week. Without the calculator. It'll take 5 minutes. Everybody will be able to do it. This week, right now, we want to do this. Right now, we want to graph y equals 3 sine of 2x minus 4. All right. Step 1. Now, I rarely do this, but I'm going to write out the steps. I rarely do this. Draw the parent function. We are now going to take these sine and cosine graphs and transform them. This is hard stuff. I had an alum call me a couple weeks ago because they were struggling with how to do this, who passed the AP Calculus exam with a 4 or a 5. This is hard stuff. So the parent function here, you should have some axes. Keep it very big. Okay. Parent function sine of x. I'm going to draw that. I'm going to start here. Going to come up, down, up. Then I'm going to come down, up, down. We know this graph goes on forever. I'm only asking you to draw 2 periods. So from negative 2 pi to positive 2 pi. Here's one period, right, from 0 to 2 pi. Here's another one from negative 2 pi to 0. So that's step 1. Always draw the parent function. It'll either be sine or cosine. It's one of the two. Step 2. Let me see how I did this. I want to make sure we're doing it right. Go ahead and take care of this right here. Remember, there's a 3 outside. Does anybody remember what that does to the function? Stretches it, so you multiply every y value by 3. So right now, this y value is at positive 1. We need to take it upstairs to positive 3, so right here. This y value is at 0. We're going to keep it at 0. 0 times 3 is 0. This is at 0. We're going to keep it here. So I'm going to put these blue dots here so I know I can. So let me, in fact, just connect this much. Okay. Now I'm going to take this negative 1 down here a little bit to negative 3. Come down here. And then I'm going to come right back here to 0. Because 0 times 3, still 0. Now I'm going to take this negative 1 downstairs a little bit to negative 3. Bring it downstairs. I'm going to keep this right here at 0. I'm going to take this upstairs to 3. And keep this at 0. I have now multiplied everything by 3. The scales are a little bit off because I'm going to have to shift down. So, don't have enough space. Okay, any questions on that? You must stop me. But do it in pieces. It's not too hard. Okay, now deal with the minus 4. So just bring everything downstairs by 4. So the positive 3 comes down to negative 1. Here's negative, so we should probably label this. So 3, this is positive 1. Here's negative 1. Here's negative 3. So the positive 3 will come down to negative 1 right here. Okay? And again, the pink graph means nothing to me anymore. I'm only dealing with blue. Because I've already made one transformation. So pink is useless at this point. Okay. Now, this 0 is going to come down here to negative 4. Okay, 0 comes down here to negative 4. Then we come up here, okay. Now this 0 comes down to negative 4. This negative 3 comes down here a little bit too low, I apologize, to negative 7. See, this was a mistake. I should have started the graph up and had less going up and more coming down. I didn't see that. Okay, down to negative 7. And this 0 comes down to negative 4. Questions on the black so far? And now make the exact same adjustments over here. So this negative 3 comes downstairs to negative 7. This 0 comes downstairs to negative 4. This 3 comes downstairs to negative 1. And this 0 comes downstairs to negative 4. Ouch. Questions on that? So now we've got black. So now I'm going to make one last transformation. Any question?
How do you know what the minimum is?
Because, okay, so do you agree that I knew the minimum of the pink graph was negative 1? Sine goes from negative 1 to positive 1. Okay, so then I multiplied by 3, so this positive 1 became 3, and the negative 1 became negative 3.
Oh, so we're using the blue?
Right, yes. So we go from pink to blue, blue to black, and now there's still this 2x here we need to deal with. Okay, we can't use black again. Dark blue, that's fine. Gonna deal with this. So I'm multiplying inside by 2, which means what? The graph is going to be compressed. Inside multiplying by 2, remember, we do the opposite. We do the opposite of what it says if it's inside. If it says multiply by 2, we divide by 2. Okay? So, let's see what's going to happen. Well, the coordinates of this point right here, right, are negative. What is the x value here? If you think about it, what is the x value?
Pi over 2.
This is pi over 2. This is pi over 2. This is this point right here. Pi over 2 comma 1. It's right here. So now what happens? We divide it by 2. So instead of being at pi over 2, we move this way to pi over 4. Pi over 2 divided by 2 is pi over 2 times 1/2, which is pi over 4. Questions? So this point, which used to be here, needs to move left a little bit. So right here. This point, which used to be at pi, is now at pi over 2. So this needs to move here. You're starting to see the graph will be compressed. The graph will be compressed. Okay, this point, so we already dealt with this, now we got to deal with this. This used to be at 3 pi over 2. Now it's going to be at 3 pi over 4. So bring it over here. This point used to be at 2 pi. 2 pi divided by 2 now will be at pi. Where is pi? Pi is here. Right here. So notice I just shrunk the period. It used to take me from here to here, from 0 to 2 pi to make one cycle. Now it just took me from 0 to pi. And I can just do it all again. This should probably come up a little bit. So notice, on the right side, and I'll do the left side in a second, on the right side, what we have in dark blue goes twice as fast as what we had in black. Right? In black, we went up, down, up, one time. Here we go up, down, up, twice. Is that clear to folks? And then you can do the same thing over here. I'm not going to worry about this right now. I mean, if you can just get up to here, that's the key for right now. Now let's do some analysis. Let's do some analysis of this graph. Let's ask of this blue graph, midline, amplitude, period. Of the blue graph, dark blue, because we don't care about any of the other ones. Only dark blue. Max and min. So the maximum of the dark blue graph, -1. The minimum of the dark blue graph, -7. Now we know the formula to find midline, amplitude, and period. Let's go through it. We know midline. We know midline. Amplitude is max minus mid. The max is -1 minus -4, 3. And the period, how long does it take to complete a cycle? Pi, up, down, up. All right. So now, here we go. Here's the big realization. Here we go. The amplitude is right here every time. Every time. The amplitude is right there every time. The midline is right here every time. And the period is always this. Always. 2 pi divided by whatever is here. Always.
So if you know amplitude and midline, you can solve for.
Yep. And if you know the amplitude in the midline, you can solve for the maximum using the formula here. So let me end by saying one last thing. And we still have some time. The general formula for this kind of graph is the following. Y equals A times sine of bx plus, call it m. Why are we calling it this? Because the absolute value of A equals the amplitude M equals the midline, and 2 pi divided by B equals the period. Every time. Every single time. So, now that you know this, here are the strategies, here are the steps for doing all of these problems. Step 1, draw the parent function. Step 2, lightly, keyword is lightly. No. Step 2, map, which means midline amplitude period. Step 3, max and min. Step 4, lightly draw in the max, the min, and the midline, just so you kind of know where the drawing should end up. Lightly draw in the highest point, so I would have lightly drawn in -1, lightly drawn in -7, and drawn the midline at -4. And then 5, solve each transformation individually. Okay, got to follow it in this pattern.